Hi there. We're going to work on solving equations when the variable ends up being on both sides of your equation. And I've just pulled some practice problems out of the website. And you may find that some of these you know how to do and you just want to fast forward to the type of problem that you want to do. I'm going to hit about 7 different types here that you're going to see on this homework assignment. So this is kind of your first one, your basic one. You've got a variable v that's on both sides and you've got a number on both sides. This is sort of your basic type of problem. So the first thing that I'm going to want to do is go ahead and get the v's together on one side, the numbers together on the other side. Now I can go either way with the v's, but I usually try to do something that's going to try to keep them positive. So to move this, I'm going to move this negative 3v over to the other side. So I'm going to add 3v to both sides of the equation. Over here it's going to cancel out, but on the left side I have a negative, that's like a negative 1v, and a positive 3v, that would combine to 2v. And then the rest of it I just leave there. And if I'm going to move my variables to the left side, that means I got to move my numbers to the opposite side, so I'm going to move them to the right. I'm going to take this minus 4 and add 4 on both sides. Then I have 2v equals, that'll get me a negative 12 when I combine it, divide by 2, and v is negative 6. So that's your first type, very basic, where you move the v's or the variables one way, numbers the other way. All right, let's try another one. This one's not very difficult, but there's one key thing that I want you to recognize on this. If you end up with a scenario where there is only a variable on one side, or maybe only a number on one side, that kind of dictates which way you have to go. If the only thing that's sitting over here is a variable, then whatever I got to do, I got to move my variables to that side. Even if it messes up my liking them to stay positive or whatever, if the u is the only thing here, then the u's got to go on that side. That means in this problem then I'm going to add the 7u to the other side. And now that worked out ideal in this particular problem, but it doesn't always. I may have ended up with a negative number here, and that's okay. I end up with a positive 6u though, so that worked out all right. And then I'm going to take and divide both sides by 6, and so my u value looks like it's going to end up in negative 5. Okay, so that's just kind of quirky because on one side you only have one term. Here's our next example, and these are just going to gradually get a little bit more involved. So on this one we have parentheses involved. The very first thing we want to do is go ahead and get rid of those parentheses by distributing. 5 times 3y gets me 15y, plus 5 times 4 is 20. Once you distribute, you're rid of those parentheses and you're back to just a normal problem where you would be solving. And that means I want to get my y's together on both sides. If you take a peek at this, it's kind of funny because if I move my 15y to the other side, it doesn't really matter which way I go with this, the 15y's cancel out on both sides. So the y disappears and all I have left is this statement right here. Now this is going to happen to you, that it kind of randomly pops in there every once in a while where the variable drops out entirely. They try to mix it up like with these parentheses or something so you don't notice it right off, but in the end the y's disappear and I'm left with this statement here. And my job then is to look at the statement that's left after the variable drops out and decide, is that true or is that false? Well, I'm going to say in this case that 20 does not equal negative 16. That's a false statement. What that means to me is that there aren't any values for y that I could ever plug in that's going to make this original equation true. So this would be a no solution kind of scenario. Now if I were to work through this problem, and I don't know if this happens on any of the future ones, I don't know that it does, but if I had worked through this problem and right here I was left with 20 equals 20. Okay, well that is a true statement. And what that would mean is it doesn't matter what I'd plug in for the y here, it would always work out to be a true equation. Now that's if it was 20 equals 20. And then I don't write no solution. At that point, I forget the wording that Hawks uses, but it's ultimately all solutions or infinite solutions or something like that. And that's the route I'd go. So it all depends on if this is true or a false statement. Here's a problem that has some decimals in it. Now there's a couple ways you can approach this problem. What Hawk sometimes likes to do, and I think this is a good strategy too, is the decimals kind of make it look ugly. So if you want to be rid of the decimals, you can just look at each one of them and decide, I wish that was like a 19 instead of a 1.9, or I wish this was a 32 instead of 3.2. If I could just take all of these, if you look at them, I would like to move that decimal one place over on each one of those so that I don't have all the decimals in there. Well, to move a decimal one place to the right, I would just multiply by 10. If I wanted to move it two places to the right, then I'd multiply everything by 100, or and so forth. But in this case, the only one I could find was this one that everything needed to be moved to the right one place. Now, if you come across one that maybe this needs to be moved to the right once, and this one maybe needed to move to the right twice for it to be rid of the decimal, well, then you're going to multiply by whatever the most you need to move it. If I have to move it twice, this one is not, but if I did, I'd multiply everything times 100. Now that's going to build your numbers up kind of big, but at least you don't have the decimals. In this particular example, I'm going to take everything times 10. Now when I take it times 10, it's like every single term times 10. So I'm going to take this side times 10. I'm also going to take this side times 10. Everything times 10. So I'm taking each term. If I multiply by 10, it moves my decimal over one place. That turns into 19V. But this 2 turns into a 20 when I distribute that. On the left side, when I take the 10 times everything, it moves it to the right one spot, so it's a 32V minus a 33. Now you can see this problem doesn't have any decimals, and maybe that's easier for you to work through. I'm going to get the V's together on one side. Like I said earlier, I kind of like to work it so that I keep my V positive, so I'm better off to subtract the 19V. And then I'm left with a negative 20 equals 13V. Oh, is that right? 13V, yeah. Okay, so then, and then minus 33. Then I'm going to move, if I move my V's to the right, my numbers have to go to the left. That's going to be a 13, positive 13 equals 13V. Quick little divide by 13. V ends up equaling 1. Now, I was able to work through that problem and never have to grab my calculator out to do that. The thing is if you're going to end up using your calculator to work with these bigger numbers here, then why not just get your calculator out and work with the decimals and not mess with the multiplying by 10. The multiplying by 10 is a strategy that sometimes helps you to be able to do this a little bit more mentally and not have to always go to your calculator. If you wanted to just work through it with a calculator with the decimals and just know that you're going to have a bunch of decimals, your answer would still get you to this V equals 1. Either way. This was a pretty messy one that I thought would be a good one for us to go over. You have parentheses on both sides. You're going to have to work on getting rid of those first, which means some distributing. But the thing that I thought was a little bit tricky about this was the minus sign that's right here. When you distribute, you're taking a negative 8. That is making that 8 negative, and I'm distributing a negative 8 through there. Over here, it's just a positive 8 that I'm going to distribute. All right, on the left side, I'm still going to have that negative 2 out front. And now I'm going to distribute negative 8 times y and negative 8 times 6. On the right side, distribute. And then that negative 7 hangs out out at the end. In this one, it's messier than the previous ones because I have multiple terms going on here on this left side. I want to clean this up, and I want to clean this up before I start moving things left and right. Let's just start with this whole thing. This 8y is the only y term, but these two, there's no sense in having two separate numbers on that same side. Let's go ahead and just combine those together. If you have a negative 2 with a negative 48, those could combine to just a negative 50. And then I'd still have my negative 8y. Okay, that's cleaned up. I can't combine those because they're not like terms. But let's go over to the other side and let's see if there's any like terms we can combine and get that simplified. Right here. These are both just numbers that could combine together. No sense in writing those as two separate terms. A negative 16 and a negative 7 would be a negative 23 there. Now it looks like a previous problem. Let's get our y's together on the same side. I'm going to get my 8y over here with my 32y, so add 8y to both sides. Remember, you're always trying to, you need these to cancel, so you're always doing the opposite sign. I didn't emphasize that. I'm guessing you know that from your previous solving homework assignments, but to move it to the other side, you always have to have the opposite sign there. So since it was a minus 8y, I had to add 8y. And that's 40y minus 23. All right, y's went to the right. Let's take numbers to the left. It's a minus 23, so I'm going to add, because I've got to do the opposite sign. Negative 50 and a positive 23. I think that's a negative 27. Ooh, this is not very pretty. All the other ones kind of came out nice. Finally, we're getting one that does not, and that will certainly happen. I'm going to divide both sides by 40, and that doesn't divide nicely. What you're going to want to do is at least reduce it if you can, but, you know, like 3 and 9 kind of are the only things that go into 27, and they don't go into 40. I don't think that's going to reduce for me. So I'm going to be done with that fraction, and I'm just going to type it as my final answer, negative 27 over 40. And now we have the ones with fractions that everybody loves so much. Well, the reason it's hard to work with fractions sometimes. So the strategy, just like earlier when we multiplied by 10 to get rid of decimals to kind of clean it up and make it look nicer, same deal. We're going to multiply by something that's going to clean this up and be rid of all the fractions. To do that, to decide what is it I could multiply that would get rid of all the fractions, I have to look at what 5, 8, 4, and 2, what number would all of those go into? And so sometimes it's really easy to tell, sometimes it gets a little bit bigger, but I think 40 would be a number that all of those would go into. If I take every single one of these terms by 40, and think of it like a 40 over 1, since they're all fractions, I bet you I could get rid of every single fraction there. So you're multiplying by the least common multiple is what it is. The least common multiple, the smallest number that all of them will go into. All right, so I'm going to come over here and just write 40 over 1. That's what I'm going to multiply that term times. Over here, 40 over 1. 40 over 1. 40 over 1. Now before I multiply, I'm going to do some reducing. That's the whole point. By choosing 40, every one of these is going to reduce nicely. Here, 40 and 5. 5 goes into both of them. 5 goes into 5 once. 5 goes into 40 8 times. Here, 8 goes into 8 once. 8 goes into 40 5 times. 4 and 40 reduce. So 4 goes into 4 once. 4 goes into 40 10 times. And the last one, a 2 and a 40 can reduce. 2 goes into 2 once. 2 goes into 40 20 times. Now I've got a lot of colors. I tried to help make this look like, not get too big of a mess, but what I'm left with here is this 8 times this negative. Now this 5 is gone. So if you look at your denominators, they're both 1. When I multiply, remember you multiply fractions straight across. Ultimately I have an 8 times a negative 1. This isn't subtraction, this was being multiplied by that. So 8 times negative 1 would be a negative 8. And I could put it over 1 because that's the denominator as I multiply straight across, but I'm not going to. Why mess with it? That was my whole goal, was to get rid of the fractions. All right, on this next term, I've got a 5 times a negative 3. 5 times negative 3. That's a negative 15. Equals Would have been nice if I didn't have all these negatives, but every single term here was negative. So I've got a 10 times a negative 5. That's negative 50. And again, I'm not even bothering. Every one of these I would take 1 times 1. 1 times 1. The denominator would always be 1. And there's no sense in writing it as a fraction if the denominator is 1. And again, that was my goal, was to be rid of the fraction anyway. This last term, I've got a 20 times a negative 3. That's negative 60. Again, we've managed to get this equation then written with no decimals, no fractions, nothing ugly, just your basic problem. I missed my V right here. Did you catch that? You're supposed to tell me when I goof up. Okay, here we go. Let's get these variables on the same side. I'm going to move the 50 to keep it positive. So I'm going to add, remember opposite sign, add 50V to both sides. And then that's, okay, so that's going to be a 42V minus 15 equals negative 60. Variables went left, so numbers go right. It's a negative 15, so I'm going to have to add it to do the opposite. 42V equals, this just ends up being a negative 45. That does not divide as nicely as I would like, but that's all right. I will make it work. V equals. Now this one, last time it didn't reduce, but I know that 3 would at least go into both of these. Would 6? No. So maybe 3 is the best I can do. 3 would go into 45 15 times, so negative 15. 3 will go into 42 14 times. That's going to be my final answer then. All right, so main goal here was to try to get rid of the denominators on that. We've got one more that's going to be like that. All right, this is the big dog. It's got the fractions and the parentheses all in one shot. Okay, the first thing I'm going to do, though, is still, and the strategy can vary, but I'm going to go ahead and get rid of my parentheses first thing. I don't know if Hawks maybe chooses to get rid of the fractions first. The order that you do that can vary. I'm going to think of this, though. I got to take a 1/6 times both of these. And to multiply, I always like to think of them as both fractions, because you multiply fractions straight across. The numerators times each other, the denominators times each other. So when I take 1/6 times z, I'm going to have 1 times z and 6 times 1. That's going to end up a z over 6. All right, minus, let's do it again. Take the numerators times each other, 1 times 3 and 6 times 1. Now that's actually a minus though, so I put a minus sign there. I'm going to have a minus 3 over 6 equals, now let's go to the other side, and we're going to do the same thing. I'm going to distribute, but I'd like this to be like over 1, and now multiply. Don't miss that this is negative right here, so when I take a negative 3/4 times z, that's going to end up negative. And if I multiply my numerators, I'm going to have a 3z, and my denominators are 4. Now let's do it again to the next term. Negative 3/4 times the 1 is just going to be a negative, nothing changed here, you're just multiplying by 1, so it just looks like that. And now it's a problem like the previous slide where you have fractions throughout. You have to find what is the number that all of your denominators could go into. So I've got 6s and I've got 4s. And you have options, but you always want to pick the least common multiples so that you don't end up having a bunch of reducing or you don't get bigger numbers than what you have to. So I could go with 24, but you know 12 is a better option. 12, both of these numbers would go into 12. I'm going to take everything times 12. So this is going to be 12 over 1 that I multiply by. This is, again, a 12 over 1, 12 over 1, 12 over 1. The reason we do that is because we can always reduce then. This 6 and 12 can reduce. And then I have, when I multiply straight across, I'll have a 2z over 1, but I'm not going to bother with writing it over 1. Let's do it again. This 12 and 6 can reduce. So I end up with my numerators being 2 times 3. Denominators are just 1. Don't miss your minus sign there, so it's going to be a minus 6. Let's do it again. Reduce the 4 and the 12. So my numerator is 3 times 3z, that's 9z. Don't forget the little negative that's sitting there. I'd put it over 1, but I'm not going to mess with it. Last one, 4 and 12 can reduce. So 3 times 3 is a 9. Don't forget the negative. Don't need to write it over 1. And now I'm to that point where I'm more comfortable. There's no fractions. It's easier to work with. I'm just getting my z's on one side. I'm going to choose to move the 9z to keep everything nice and positive. That's an 11z minus 6 equals negative 9. Z's went to the left, so my numbers will go right. Going to add the 6 so it will cancel. 11z equals negative 3. Divide by 11. No reducing on that one. And that's your final answer. All right, so I hope this helped and give you a little example of each of the different types that you're going to come across on your assignment. Good luck.